Hello, hello, hello. Hi, everyone. We're gonna go ahead and do the test one review. All right. So let's go ahead and just begin. So in this packet, if you haven't looked through it already, um, I'm trying out something new-ish sort of with my teaching where you can see that 1 through 5 is sort of a same layout copy of 6 through 10. The only question I accidentally didn't keep exactly the same type was number 7 and number 2. Um, I saw a colleague told me about this, saying that it can help you guys, recall retention if we, basically do 2 laps around the Unit 1 material. So just keeping that in mind, if you're wondering why it feels like there's a multiple thing happening, or like the same things are happening as we go through this video. Um, I'm not gonna, I'm not gonna skip it, so I'm not gonna do 1 and then 6, and then 2 and then 7. Ideally this is what you guys are supposed to be doing, so just keep that in mind. Okay. But for the sake of the review, I am going to try to get as specific as possible. If I miss something, just let me know. Okay. By the time you're watching this, hopefully you're watching this on Thursday, the test will be due. The test will be administered on Friday. I still haven't decided for the test if I'm going to give you like the whole weekend to do it. I don't want to do that because I feel like the chances that Tarleton are that you guys may opt to cheating on the test, which I'm obviously not going to be a fan of. But we'll see. Maybe I'll do something like in the middle where I give you guys till like 8 a.m. the next day or something like that. Either way. All right, let's go ahead and get started. So first, this question set is evaluating limits. So these first 3 are the exact entries, and these guys are infinity. So let's start here. It says x going towards -5. Well, plugging it in, I can see that I get the top will be 0, and the bottom that doesn't look like it. Well, actually, it will be, but it doesn't look like 0 right away. So I'm gonna go ahead and adjust that, and then -15, and then now it's looking like 0 because you have 25 minus 10 minus 15. So 0 over 0. So that's obviously not an answer, and we need to do some more work into this. So what we're going to do is we're going to go ahead and take out a common factor. Now the top has that luxury of being that difference of squares, and 25 is a square, x squared is a square, so we know the top can be rewritten as this. And we know that the bottom, because when we plug in -5, we'll have a factor of x plus 5. We just technically don't know what the other part of this is. So let's go ahead and figure that out on the side here. So dividing that bottom polynomial by x plus 5. We got x squared plus 5x. Subtract, we got 0. We get 2 minus 5x, that's -3x, minus 15, and multiply by -3 to get -3x minus 15. Now that'll perfectly subtract out, so that is indeed a proper factor. And we get x minus 3 as the remainder, or not the remainder, but as the quotient of what was factored out. That cancels out, and you're left with x minus 5 over x minus 3. From here, we can use the substitution method where we plug in -5. So I got -5 minus 5 over -5 minus 3. That's going to be -10 over -8, and that simplifies to 5 over 4. And that's going to be your answer. All right, next part we see here. First, just doing the classic substitution method. The bottom will be 0, the top will be 9 plus 7 squared minus 4. That's going to be 16 under that square root. Square root of 16 is 4, so 4 minus 4, 0, that's 0 over 0. So again, similar situation. Let's multiply the conjugate of that top part. X squared plus 7 minus 4 over x minus 3 times the square root of x squared plus 7 plus 4 over square root of x squared plus 7 plus 4. We go ahead and multiply this. We get x squared plus 7 and then minus 4 squared. So it's going to be 16. Keep in mind we're technically doing this times this squared, which will get rid of the square root. So that's why it almost looks like nothing happens. And the bottom will leave that factored. X minus 3, the square root of x squared plus 7 plus 4. And then from here, we'll go ahead and simplify that to get x squared minus 9 over x minus 3. That's going to be a difference of squares, by the way. Let me finish rewriting this. So that's going to basically be x minus 3, x plus 3. X minus 3, square root of x squared plus 7 minus, or no, minus? No, plus, excuse me. Plus 4. That cancels out. We're left with x plus 3 over the square root of x squared plus 7 plus 4. Okay? Then from here, we're going to try the substitution again. And this time it should work. The top will be 6, and the bottom, that's going to be 4. So 4 plus 4 is 8. So 6 over 8 or 3 over 4. All right. Next, we're going to do the plug-in method first. So we have the square root of 2 plus 7 over 6. Well, 2 plus 7 is 9. Square root of 9 is 3. And then we have our limit. Okay, so that one's actually pretty straightforward. Okay, neat. All right. Let's move on into now limits involving infinity. So we see here that we can just use the polynomial tricks right away. For this guy, we can see that it's going to be considered top-heavy, to where the degree of numerator is greater than the degree of denominator. So that means we just listen to this guy, and this guy's limit will be towards infinity. It's going towards negative infinity, so that means x to the 3 for any negative number will still be negative. But it's getting multiplied by a negative, so a negative times a negative will cancel out, and we're left with infinity. Alright, over here, the degree of the denominator is definitely bigger. So that means we just go towards 0. Over here, both degrees are the same. So we take the coefficient of the leading coefficient of the top, divided by leading coefficient of the bottom, and then we can definitely simplify that to just negative 2. And those are our answers. Alright, pretty straightforward. Let's move on. So then we have the next part. Identify any vertical asymptotes for the functions. Okay, so this is going to use one of our ideas from chapter 1, part 1. Look at the power. We can say, okay, that power is even. So that means it doesn't matter if we're coming from left or from the right or all together. That's gonna go ahead and be an infinity, just plain Jane. However, here we have a similar. Oh, and don't forget that this repeats. It's minus this guy, or the minus blank and this here have to be the same. Here, same thing, they're the same, but this is being taken to a power of 1. 1's an odd number, so that means we have to pay attention to where it's coming from. If it's coming from the right, then it's positive infinity. If it's coming from the left, it would be negative infinity. Alright, pretty straightforward. Number 3. Use the graph to answer the following. Write D and E are undefined where appropriate. Okay, f of -4, I get 3. The limit as x goes towards -4, we see a discontinuity. So that's going to just be does not exist. Here, the limit as x goes towards -1. So we see here that's going to be 4. It doesn't matter from the left or from the right. It's just going to be there, straightforward. F of 2, that's going to be -1. F of 4, oh, it's actually not going to exist. There seems to be a whole discontinuity. Then we have as x goes to 2, where's 2? Okay, so right here, we see that it's a jump discontinuity, so that does not exist. As x goes towards positive infinity, so that means we're just going to go towards the right, and it seems to be implied that this is going to keep going on forever. So that's going to be forever, but downward, so negative infinity. And lastly, f of -2, that's just going to be 1. All right, pretty straightforward. Remember the ideas with limits. Just to recap, you know, as x goes towards an entry, we have to ask if it's coming from the left or from the right. If we see that it's written as this, then it's coming from the left. If we see that it's written like this, it's coming from the right. If there's nothing at all, then it's coming from both. And both the left and the right must. Oh, sorry. I just realized I wasn't on screen. So if we see nothing, then that means it's coming from both. And both the left and the right must match. So please keep that in mind. Okay? Alright. Number 4. Is the function continuous at x equal to 3? If not, label discontinuity. Okay, so we're going to have to check both sides because it's where a piecewise function broke. The limit as x goes towards 3 from the left is going to be using this guy because x less than 3 is that's the left, so negative x plus 2. We can use classic substitution ideas to get our answer, and that it's going to be -1. Then we have the limit as x goes to 3 from the right, and that's going to be 2x squared minus 3. So that's going to be 2 times 3 squared minus 3. That's going to be 2 times 9 minus 3, 18 minus 3, 15. Yeah, so there is definitely not continuous here. Oh, I forgot to check. Okay, so this was step number 2, right? And step number 1 would have been to just check f of 3. So f of 3 is just using that top guy since it's the only one where it says x can be equal to 3. And we saw that that was 15. So I'm just going to go ahead and copy and paste that. And then 3 we can't check because the limit as x goes to 3 of this function does not exist. And it seems to be a jump discontinuity. Alright, next, number 5. This function continues at x is equal to -2. If not, label the discontinuity. Okay, so x equal to -2. Well, we're definitely going to see something, because when I try to plug it in, I am going to end up dividing by 0 at least. Let's double check everything just in case. Although dividing by 0 is already bad enough as it is, but let's just do it just so we can see the whole picture. We got 4 plus 2 minus 6 over 0, 0 over 0. Okay. Then we're doing the limit as x go towards 2 and -2. And right away we're gonna see it's not gonna work because if we would have tried substitution, not having this step presented to us, we sort of lean on that little technicality. So we do have to simplify this function again, and kind of like the reason why I wanted to show it out loud is we see that the top part has 0. So we know we can divide this out. Or not, okay, we don't know we can divide it out. We technically don't. But we know that the polynomial that has a root of -2 can divide out, or not the polynomial, the linear equation that has a root of -2 can be factored out of here. Well, that linear equation that has a root of -2 just happens to be x plus 2. So technically, right, we can go ahead and I'm just going to do that by scratch this time. X squared minus x minus 6. Make x equal to x squared by multiplying it by x. X squared plus 2x. Checked it out. We get that cancels out. Negative x minus 2x is negative 3x minus 6 minus 3. That will perfectly factor it out. So we can instead see the limit as x plus 2, x minus 3, x plus 2. That'll cancel out. And you're left with the limit as x goes towards -2 of x minus 3. And then from here, you can go ahead and just do the substitution method. And you would just get -5 as your answer. Oh, wait, that wasn't the question. The question is determine if it's continuous. So that was us getting the limit, right? But that doesn't actually solve the problem. I got a little ahead of myself. And then we would maybe tease the idea of checking step 3, but again, we have the scenario where we can't really check it because f of 2 does not exist. So what kind of discontinuity is happening here? Well, it's just a whole discontinuity, or it's a removed discontinuity. All right, and that's it for that one. Let's do a lap, and we're gonna go back to evaluating limits. So we got this following expression as x goes towards 2. Okay, let me do a different color. Actually, no, let me keep the same color because I think it doesn't matter. The color is more for me than for you guys. Just trying to differentiate these papers for fun. Let's plug that in. I get 2 squared plus 2x minus, or not 2x, times 2 minus 8. Yeah, it's definitely going to be 0. 2 squared minus 2 minus 2. 4 plus 4 minus 8 over 2. No, sorry, I'm going too fast. 4 minus 2 minus 2. 0, 0. But we notice that both of those guys have a factor of, have a linear factor of an equation, a linear equation that has 2 as its root. So they both should be divisible by x minus 2. X minus 2. X minus 2. Yeah. Okay. While this dries, let's go ahead and do this first one. X squared minus 2x. Subtract, we get 0. We get 2x minus a negative 2x, so 2x plus 2x, 4x minus 8, and times 4. And that should perfectly factor out. Here it was a 2. Okay. So we have x here. X squared minus 2x. Subtract that. We get 4x and then minus 2. Oh my gosh, I didn't copy the middle part correctly either. It's minus x. My mistake. Okay. Okay. Well, in that case, it's not going to be 4, but negative x plus 2x is just going to be x altogether. Oh, so then we can see here that that's just going to be 1. Because x times what gives me x? Well, just 1. Okay, we go and make that minus now. Okay. And then we have that we can rewrite this expression, the limit, as x goes to 2, as x minus 2, x plus 4, x minus 2, x plus 1. Cancel those out. And we get x plus 4, x plus 1. From here, we can just do the classic substitution method. And we get 6 over 3, or just 2. Because 6 divided by 3 is 2. Okay. Alright. Let's go ahead and do this one next. For this one, it's probably going to be 0. Yeah, it definitely is. Okay. We have 1 squared plus 3 square root minus 2 over 1 minus 1. We have 2 minus 2 over 0. That's going to be 0 over 0. So we have to check this, multiply by the conjugate. Let's do it. Let's do it. Come on. We got this. That becomes x. Technically, this, and we're multiplying this. So square root of x squared plus 3 squared, which cancels out square root. We're left with x squared plus 3, and then minus 4 over x minus 1. Don't know where the minus 2 came from. Times square root of x squared plus 3 plus 2. Sorry. I need a stretch as of recording this. I'm a little bit tired, but we got this, guys. Let's go, go, go. Hoorah! That was so dumb. I'm so sorry. Okay. Man, you all better be watching these videos. I'm making quality content here, so y'all know. We got x squared minus 1 over x minus 1 with that whole expression that has the square root. X squared plus 3 plus 2. Difference of squares, well, let's simplify that. We got x plus 1, x minus 1, x minus 1, and that's square root. Cancels out. And now we just plug in 1 for x plus 1 on the top, and the square root of x squared plus 3 plus 2. And that's going to be, or let me do an arrow. That's going to be 2 over 4 or just 1/2. Okay. All right. Let's do this one next. For this one, um, let's do our substitution trick here. First, we got 4 minus 2 over 10, 2 over 10, 1/5. Okay, that's the answer right away. For here, let's see, we have um, for here we have a bottom heavy function, so that means it's going to go towards 0. For here we have a top heavy function, so we have to pay attention to this guy. It's -4 times x to the power of 3 with infinity, so that would be positive, that would be negative, so negative infinity. And over here, those coefficient matches, so we have -4 over 3, can't simplify any further, and that is my answer. I forgot about the system. Right. On the last legs, let's go. Okay. 7's different. Perform the limit, then identify the vertical or horizontal asymptotes for the function. Remember, and I haven't finished writing the test yet, but do remember that if I ask you the horizontal asymptote question, I'm just gonna go ahead and give you something like this, where it's you don't have to check both sides, but I prefer to write it like this, like perform the limit and then identify if there's a horizontal or vertical asymptotes, if any. Or actually, I'm just gonna tell you, like, identify it. Don't say it. I wrote it here, like any, but I think for the test, I'm just gonna tell you, like, hey, there's one. You better find it. All right, and you better show your work to find it. But I'm gonna save that for the end. Okay. Over here we have, the same featurette where it's an explicit power being taken to to the consistent constant. So we know that because it's even, that it's going to go towards infinity. Now, granted, if it was asking it for positive, for positive, if it was coming from the right or from the left, it's still going to be infinity. When it's odd, that's when we have to really care about which way we're coming from. All right, this one. All right, as x goes towards infinity with this expression. Okay, so from here, you can't really do any tricks other than rewriting this whole thing because you just have infinity going towards infinity. Excuse me, I'm gonna sneeze. Sorry about that. Okay. All right. So from here, I'm gonna take out x squared because I'm gonna go ahead and force that root limit theorem that we've been using, or that theorem that states that when we have 1 over r, or 1 over x to the power of r, and the limit's going towards infinity, that's going to be 0. Okay, so let's factor out the x squared. We got 9 plus 2 over x squared, and then we take out the x squared. It's absolute value of x, square root, as 9 plus 2 over x squared. Okay, from here, we have to remember that we're going towards positive infinity. So that x, in order for it to stay positive, if the values are positive, can just be plainly written as x. So x divided by x square root of 9 plus 2 over x squared. Those will cancel out, and you're left with 1 over square root of 9 plus 2 over x squared. Doing the composite limit idea where we take the infinite limit inside this root, because from here, if I take this limit to infinity, I'm going to go ahead and see that this function, 9 plus 2 over x squared, if I take x to infinity, that's going to zero out, and we're just going to be left with 9. So the actual limit used is going to be 1 over square root of 9, which is just 1 over 3. Okay, next for 8, we have f of negative 2. So that's going to be exactly negative 1. F, or the limit as x goes to 1 for f of x. Although f of 1 is 4, via this line, we would write 3, since from the left or from the right, it's coming to 3. As what's the limit as x goes towards negative 2? This is not going to exist because from the right, it's going to go towards negative 1, which is what we got. From the left, it seems to be doing this like alternating up and down infinite thing. And that's not even concise. It doesn't even match negative 1, so it just doesn't exist. F of 1 is going to be 4. F of 3 is going to be negative 2. F of x as x goes to 3. Well, it's a jump discontinuity, and they don't coincide, so that just doesn't exist plain Jane. As x goes towards infinity, it doesn't seem to stop, so it's going to also go towards infinity. And as f is negative 4, it's going to be 4. Alright, so number 9. Is the function continuous at x equal to 4, if not labeled discontinuity? Okay. Well, let's check first. F of 4. We have 16 minus 16 over 4 minus 4, 0 divided by 0. So definitely not continuous. Um, it's discontinuous, but we need to know what type. It's probably going to be a whole function, or a jump, or I mean, not a jump, a removed. But let's go ahead and just do the math, practice it. You never know. All right, from here, we see that that's just a difference of squares. So I'm taking the limit as x goes to 4. We can just rewrite this as x minus 4, x plus 4 over x minus 4. That's going to cancel out, and we're just left with the function x plus 4. That we can just use substitution. We should get 8. That's our answer. Can we check condition 3? No, because f of 4 does not exist. And they do match. We get a limit value. So it seems to be just a hole. Alright. Last one of the review. Is the function continuous at x equals 2? If not, label discontinuity, okay? Step 1, f of 2. I'm not going to go out of order this time. For 2, we're going to use the bottom one since that's what the inequality tells us. So 3 times 2 minus 1, that's just 5. Okay? And then 2 is to figure out the limits, but we technically have to figure them out from both sides because it's piecewise at that specific value. So we have 2 from the left, limit of x goes to 2 from the right. From the left, we have to use this function on the top, x squared plus 1. And from the right, we have to use that function, 3x minus 1. From here, I'm just going to use good old substitution. We get 4 plus 1, and here it's the same thing that we did over here, so we get 5. 4 plus 1 is 5. So they match. Let's check condition 3. We haven't checked condition 3 in a while. We see that f of 2 is equal to 5. And the limit as x goes to 2 of f of x is equal to 5. They match. I don't know why I capitalized that. So therefore, it is continuous. So even though piecewise functions have the potential to not be continuous, it's not always going to be the case where they are discontinuous. Alright, guys. This is going to wrap up the review. I hope you all watch this as soon as you can. It's a bit scary having a test the first week of school, however, our material frankly demands it. So please let me know if you guys have any questions. I'm gonna be in front of my computer all day on when you're watching this on Thursday, and all day on Friday for the tests. So please keep that in mind. All right. I wish you all the best. Let me know if you guys have any questions, and I'll see you all in the next video. Peace.